Therefore, what am I saying? What are these expected values? What do they do? Number one, firstly, expected values, number one, they do not reflect a single outcome, as I mentioned. They do not reflect a single outcome. Number two, they're mainly useful with repetitive action. They're mainly used with repetitive action. And finally, they are certainly of statistical significance. These are some of the points you can put up when you're using expected values. Number one, they do not reflect a single outcome over here. They're mainly useful with repetitive action, and finally they are of significance, statistical significance, so to say. Then finally, the last point we're going to look at under this is that expected values ignore the range of outcomes. What this simply means is that it gives you the worst and the best case scenario, which is one advantage because it will give you a range. Then you're able to choose the worst, you're able to have an idea of the worst and the best case scenario. What we're going to look at next is other decision rules. Obviously, we've already looked at, which we can't ignore, expected values. There are also a decision criteria. I want to move a further step, and we're going to consider what is known as max approach. We're also going to look at number 3, the min approach. Then finally, we're going to look at the minimax regret. Minimax regret approach. We've already considered this. The maximus approach is simply, you're looking at somebody who's a risk seeker. It's a risk seeker approach. And you're looking at the best possible outcome. In simple terms, when you're looking at Maximus, you're looking at the best of the best. When you have a range of outcomes, with Maximus you're going to select the best of the best. And the way I remember it, obviously as I've mentioned, it's the best of the best. Minimax, I mean, if we know what Maximus is, it's almost the opposite. It's a risk-averse person. It's simply looking at the downside of an action. Looking at the best of the worst. Therefore, when you have a number of outcomes, you select the worst, and from the worst you select the best. Then finally, we're going to look at the minimax regret, which is simply an opportunity cost approach. You're not necessarily looking at individual results when you're looking at the minimax regret. You're looking at the result of picking one against the other. Therefore, you're going to look at what you've picked against what you could have picked, and the difference would be your opportunity cost. That is the minimax regret. Therefore, what you're trying to do with this approach, the minimax regret, is that you're trying to minimize the maximum opportunity. That's what you're trying to do with the minimax regret. Now, I want you to understand that when such a question comes up in an exam, obviously the easiest part is, this is fairly straightforward. It's easy to calculate and you probably get it. The same goes for the other two. They're basically straightforward. Minimax regret, on the other hand, is quite lengthy and you probably have it at the end of a paper. So really you have to do a cost-benefit analysis. What you're trying to get in an exam is, you're trying to pass your exam. And usually minimax regret is very long. Therefore, you might want to weigh the options. Quite alright, I want you to do this in the exam, but where you don't have time, try and see where you can get better marks rather than concentrating all your efforts on minimax regret. But however, if you can do it, fair enough. But otherwise, this will give you, if you get this right, and most of the marks will be covered in these three aspects. So you might want to do a cost-benefit analysis on whether you really want to do the minimax regret. But if you can do it, however, I encourage you to do it. But if you can't, as I'm saying, weigh your options. So we're now going to look at the sort of questions that you might expect on these three items I've mentioned. I'll just read through a question. Unfortunately, I don't have enough space. However, I'll take note of the figures. The question reads as follows. Mr. B is a greengrocer or a food seller. He buys products for 20 per case. He can then sell the products for 40 per case in his store. The product is perishable, meaning that it does not last forever, because it gets damaged, and therefore it is not possible to store any food. Instead, if there are any cases that are unsold at the end of the day, they could be sold for scrap for 2. Note, purchase orders must be made before the number of sales is known. He has kept records of demand over the last 150 days. Therefore, the demand is as follows. You have 10, 20, and 30 cases. Then you have your number of days this side. You have 45, 75, and 30. Alright, so required. Prepare a summary of the possible daily margins using a pair of table. Then B, advise him on B1, how many cases to purchase if he uses expected values. Number 2, how many cases to purchase if he uses a maximus approach. Number 3, how many cases to purchase if he uses the minimax regret approach. So the first step is obviously to get the probability distribution. As we've not already been given the probability distribution. This is fairly easy. You simply sum up the 3 to get the total, which is 150. The probability distribution will be equal to number of days over total population. Therefore, in this case, we'll have, for a demand of 10, we'll have 45 over 150. The next one will be, for a demand of 20, you have 75 over 150. And finally, you have your 30 over 150. Just grab my calculator over here. 45 divided by 150 will give me 0.3. Then my 75 over 150, 75 divided by 150, give me 0.5. Then my 30 divided by 150, 30 by 150, give me 0.2. As I mentioned earlier, this must all sum up to 1. So 0.3 up there plus 0.5 plus 0.2 give me my 1. Therefore, my probability distribution, I can just wrap this. Is probability there is 0.3, 0.5, and 0.2. This gives me a total of 1.0. So we have our probability distribution. I'll just keep them in the corner because obviously I'll need to use them at some point. So we have 0.3 there, we have 0.5 there, and we have 0.2 there. Now just rub this off, so I just have more space on the board. Now we're asked to do a payoff table. It's not something very difficult. The way I like to do it is that I'll draw my grids, maybe from over here. And I have another line over here. And I have a line there. Then of course, I'll show my possible outcomes. Or maybe the decision over here. These purchases. As we've been told from the question, you can either purchase 10 cases, there'll be 10 cases over here, or you have your 20 cases over here, or you have your 30 cases over here. Then we have the outcome, which is the sales. Same, you have your 10 over here, you have your 20 over here. And you have your 30 over here. Now we may need to do a little working to know exactly what amounts need to be put and where they need to be put. So I can have my working done over this side. I'll have my decision over here. I have my outcome over here. Note, the question asks us to prepare a summary of possible daily margin using payoff table. So you have your margin over here. So your decision, obviously, you've got 3 this side, so 3 by 3, obviously the outcomes are probably going to be 9, because 3 by 3 this side, you therefore expect to have 9 outcomes on the other side. So the decision is either to buy 10 cases at 10, or you can buy 10 cases at 20, or you can buy 10 cases at 30.